Question 7 of the Calculus Knowledge Pretest asks us to match certain functions to their graphs. And in this video, I'm just going to show you ways to, using basic knowledge that we know about these functions, how to use process of elimination to find what their graphs look like. So starting with sine of x. A basic thing that we know about sine of x is that sine of 0 is equal to 0. We also know that the graph of sine of x oscillates between 1 and negative 1. So the graph that most shapes what we already know about sine is c. We can say that it starts at 0, it rises to 1, falls to negative 1, and will make its way back to 0. So it's safe to say that the graph of sine of x is c. For the graph of natural log of x, so let's just rewrite this in a way that might make this a little more clear. If we have y equals natural log of x, we can rewrite this as e raised to the y is equal to x. So we know that x can never equal 0 because there's no y that can make e to the y equal 0 true, because you can never raise a number to an exponent of any number and get 0. So we know for sure that this graph will not ever be x equals 0. We also know that the graph of the natural log of x will never be negative because there are no y values that will give us a negative number. So even if we raise e to the negative 8, for example, this just becomes 1 over e to the 8, which doesn't give us a negative value. It just gives us a very small fractional value. And the graph that kind of shapes what we're looking for is a. If we look at the x values as a function of y in this graph, we can see that as y increases, x rapidly increases, which makes sense because when you raise a number to an exponent, the larger the exponent becomes, the larger the output is. So with that, it's safe to say that the natural log's graph is a. Similarly, for an exponential function, if we have any number raised to x, as x values get bigger, this number will increase rapidly. And any negative x numbers, again, will just give you a fractional number. So we know that the negative x values are going to be very, very small. And as soon as we hit positive x values, it is going to increase rapidly. And the graph D gives us that, because you can see negative numbers all remain very, very, very small, and as x values increase, the graph will increase rapidly. So let's go down 1 and do the derivative of an exponential function. So the derivative of any number raised to x is equal to that number raised to x times the natural log of that number. And the natural log of that number is just a constant. So essentially, the graph of the derivative of an exponential function is the same graph of the exponential function, just kind of transformed a little because it's multiplied by a constant. So it's safe to say that this is actually going to be the same graph as the exponential function. And lastly, the derivative of sine of x. We know that the derivative of sine of x is equal to cosine of x. And for cosine of x, we know that cosine of 0 is equal to 1. And from that, we can tell that e is actually the graph of the derivative of sine of x, because it's the graph of cosine of x.